All right, but enough about that. So, how's everybody doing? The class seems a little, fewer people than usual, but that's okay. It's only the true that survive, the true and the brave. All right, how was assignment 2? Everybody get through it okay? Yeah. I'll be marking that sometime this week. So, let's take a look at assignment 3. We are gradually creeping up on having caught up to the lecture material. By the end of today, I expect we'll have gotten there, mostly because I think that you guys probably don't need a whole lot of instruction on how to use the Copilot plugin for VS Code, right? Perhaps that it exists, 1 or 2 examples, but I don't think you guys need that. I'd much rather get to this week's material, which is how does Git work? Which, yeah, favorable plan? Okay. But let's just take a walk through this assignment. Oh man, this one's under 15 minutes. It's going to take forever to mark. Well, except that, every week fewer people submit the darn thing. So, task 1, edit a file with VI. You'll need to download the JSON file. This should be 3 minutes of the video. Bash shell, open the file using VI. Using one command, delete the friends objects with names Bob, Mary, and Mike. So you have to learn how to edit JSON using command. Change the value of the age key to 40, not the age key in the array of friends, the age of John Doe, the top level object. Save and quit. Show the altered file contents. So a couple of specialized VI commands that are specific to JSON editing, and that's about it. Shouldn't be too bad. Task 2, a little bit more extensive. Create a small game of your choosing with built-in HTML, CSS, JavaScript using GitHub Copilot. This game can be anything you like. Record yourself creating the game using GitHub Copilot for no more than 12 minutes. If it takes you longer than 10 minutes to create the game in its entirety, that's okay, but only record the first 12 minutes of that. During these first 12 minutes, you should attempt to use the following capabilities. Ask it to generate code or use code it suggests while you type in comments or the beginning of a chunk of code. Ask it a question about the code that you've either written or have generated. Ask it how a portion of the code you've written or generated can be improved. Introduce a mistake deliberately into your code and ask how to fix it. So please make sure that you do all of those things. There will be a rubric item for each of those being present in your video. Try to use the tool in a productive, useful way, including the above cases. Explain what you're doing as you do it as best you can. Stay within reason, though. Exactly what level of success you will have using the tool will not be a factor in your grade. So it doesn't matter how much your game sucks. All right, your game could suck pretty bad and you'd still do fine on the grade. Just make sure that it's not if it sucks, make sure it's not for lack of trying. You should ultimately produce a working game, even if it takes longer than 12 minutes. Please don't try to build anything too big. Small quiz games, graphical games, dice rolling apps, that sort of thing. It's kind of, you guys remember JavaScript assignment 4, right? Where you made a game using SVG, right? You guys remember that?
Yeah.
Something at that level might even be a little bit on the complicated side. What you should maybe even have in mind is like, I know this is like my context, there's no reason for you to know this, but like there's a kind of assignment for that I usually give like a 60, right? Where it's like, well, you didn't really do much, right? But here's your slightly passing grade. Yeah, it's like, you know, if you, oh, here's an idea. Ask it to make Snake. It's really good at making Snake. I can tell you it's very good at making Snake because every single time I run client-side, I nail at least 5 or 6 people for plagiarism because they all submit to me the exact same Snake game. So Snake, that's one that you can generate with some reliability. And like, it's AI, so if it doesn't give you something, if it gives you something you don't like, you can do something else. Just make sure that like, you should rehearse it, right? Try the series of prompts before you make the video, then new project, make the video, go, right? Just try it before you record, right? I guess if there's one piece of advice that I would give for the videos, having marked only one of them, it would be, it really looks bad when you're like fumbling around during the video because you haven't practiced what you're doing in the video. And it's like, well, you know, like I accept a certain level of that, right? It's like, you know, maybe you're doing it from memory rather than having written it down. But if you're doing it from neither your memory nor having written it down, you're doing it from like the slides. Please don't do it from the slides on the video. Normally how this shows up in your grades is you get dinged for having gone over time. You know, even if you hit all of the, even if you hit all the points, it's actually, you know, a little bit of a skill to get all of the stuff in within the time limit, right? So, yeah, makes sense? All good? Okay, good. Submission is as normal, but I would like to see your game files. So if you could zip those up and send those along with your submission as well, that would be bloody marvelous. Any questions? All right. Yes?
I have one question. I installed an instance of Linux on my regular PC, WSL. Am I allowed to use that instead of opening up Mint?
Now that's an interesting question.
I'm using Ubuntu right now.
You're using Ubuntu,
Yeah.
right?
Yeah.
So what do you mean you're using Windows subsystem for Linux?
I can, if I open up my terminal, I can just say like, hey, can you run an instance of Linux, and it becomes a bash terminal.
Okay. Can I see what you're talking about?
Yeah, sure.
Oh, I see.
Yeah. All the regular things.
You may run into issues eventually.
Sure.
Yeah, it looks like it's got a little virtualized thing in there. I would prefer.
Okay, yeah.
It's better for your learning experience if you're using this one.
Yeah, that makes sense.
But it does seem like you're doing pretty well. Actually, that actually reminds me. Thank you for reminding me. Where are my Mac users at? Yeah. So I discovered, or people discovered and did this in their assignments, and now I'm going to pass this discovery on to you. If you don't know about this already, here's a quick tip. The Mac virtualization problem with ARM processors, right, will prevent you from running the Mint VM on your own machine. But you can make a live boot USB drive and use that. So let me explain to you what this is, right? Live boot USBs are commonly how people install Linux on operating systems now, right? Basically what it is, you take the USB drive, you load it up with whatever your favorite distro is, use Mint, right? Let me back up. First you download the Mint ISO, right? You get the installation disk file, right? You then burn that disk to a USB drive. There are utilities that allow you to do this, right? Once it's on the USB drive, that is a Linux operating system. If you turn off your computer, plug it in, right? And as your computer is booting, it may not boot to that by default. So you might have to open up the BIOS settings and set the USB stick as the thing you're booting from. But once you've done that, you're running Linux. Now, it is slow as continental drift because basically you're using a USB as if it were your proper hard drive, right? So it's pretty damn slow, right? Even slower than the VM, if you can imagine it. But, like, it is a proper, you can do everything in there that you would want or need to. It's not a VM, right? You are actually running an operating system using your USB drive as a second hard drive, right? But it works. And as long as you just don't click the thing on the desktop that says install Linux, that destroys everything on your computer, then you'll be fine. Make sense? Good. I think there should probably be like slides in this course on how to do that. Like installing Linux from scratch, you know? Anyway. Just remember, kids, if the BIOS is unlocked, it's your computer. Because you can do anything you want to it. So, good. Fine. Let me just publish that so that you guys can actually see it. There we go. So, I will make an attempt at getting through this with alacrity. Bloody Windows. Like, how is that over open file? How many people are, like, how much money do they think they're going to make on people accidentally clicking Copilot? You know? Ugh!
Probably user agreement that if you use it, you need all information.
Well, actually, that's already true if you've linked your login to a Microsoft account. I heard something interesting about the upcoming discontinuation of service for Windows 10.
Yes.
Yeah. So apparently, after the end of service date, which I think is in 2 weeks.
It's in this month of October only.
Yeah.
October 10.
I think is it the 10th? Yeah. So right before reading week then. That's actually the day before my brother's birthday, but that's of no consequence. So apparently you can still get your updates for 1 year as a personal person, but you're going to have to ditch your local account and plug in a Microsoft account, in which case, you have agreed to the terms of service and all of your data is their data. So, the day of Linux is swiftly coming, right? If you're not prepared, I actually, this is a thing that's going to happen. I'm going to have to, my wife has a laptop, I'm going to have to Linuxify for her, because
But then if your system is compatible with Windows 11, you can upgrade.
well, that's the thing though, is your system compatible with Windows 11? Because it's got more advanced hardware requirements as most,
Because our Mohawk PCs are also not compatible with Windows 11.
Yeah.
So these all will be also shut
Oh
down.
yeah, so what
Yeah.
happens to them October 10?
With these things?
Yeah, those are also Windows 10.
So for institutions and stuff, they're gonna charge a fee. Like for the first year, it's like $2 a computer for support. Then after the next year, it's like $4 a year a computer for support, and then after 3 years, it's like, you know,
I mean,
nothing is going to happen because IT is on strike.
actually,
Oh.
that's true.
Yeah. Nothing is going to happen because they should have planned for this 2 years ago. And certain professors in our department, Simon, have been like, you know, screaming up, down, left, right at anybody who would listen in the whole, you know, the whole organizational structure. Do you realize that we have a wrecking ball that is poised to destroy every computer on campus? Do you realize that we need development time to get every course in this department onto Windows 11? It's like, they're going to pay the fee. They're going to pay the fee until they can't pay the fee anymore. And then they're gonna have to do something about it. So, hopefully this is a problem after all of you graduate.
Yeah, honestly.
But then I have seen Windows 7 as well in some PCs.
Yeah,
They are in like 3D designing, architect and all. They still use Windows 7.
yeah, yeah, that's the other thing, is you just let service lapse. Although I wouldn't recommend that, right, because that's also your antivirus, right? And because most people use Windows Defender as their primary antivirus these days, right? Yeah, so, yeah, so, yeah, a lot of computers are not going to be able to handle Windows 11, and we're hoping, we Linux people are hoping that a lot of people decide to jump ship. A lot of the time, actually, this is the type of thing actually that spurs open source adoption among the general population. Is like when proprietary software gets so bad it starts making computers break, people start thinking open source, you know? But anyway, yeah. All of you should be fine though, because you know Linux now. Right? So,
Oh, I'm sorry.
oh yeah, sorry.
I realized that I couldn't. Okay, maybe I just don't know how to, but I couldn't like copy paste the code on the VM. Every
The
time,
code on the VM, what do you mean?
like for the assignments.
Oh,
Yeah.
you mean in the terminal?
Yeah, in the terminal.
Oh yes, that's that old chestnut, yes.
Yeah, I was. Oh my god, it was the most frustrating thing ever. My video was now 12 minutes instead of 10. I'm hoping that doesn't.
Well, it may be a minor deduction, a point or two maybe. We'll see. We'll see. I'll decide. I will not make grading decisions until I'm actually grading. So let me as good a time as any to load this thing. Yeah, it's long story short. Control C is stop program, right?
Yeah.
Control V, I don't think it's bound to anything. Another one that you shouldn't try is Control S, because Control S is suspend, right? So it just freezes the terminal. If you have a nice modern terminal, it'll tell you that it's been suspended, and it'll tell you the shortcut to get it back open. It's Control Q. But if you're patched into CS Unix, you won't get that notification. Control S will just suspend, it'll freeze it. But yeah, long story short, just right-click menu.
Yeah, I just did that.
Yeah.
Click, copy and paste.
Yeah. Yeah, you have to, like, it's a little weird because when you're working in terminal, like, you've got, like, 2 layers of cursor going on, right? Like, you've got the terminal cursor, which is only keyboard, but then you've got the second layer of like the mouse cursor where you can highlight things, right? And it's like, unless you're working with a very clever terminal program that has mouse integration, there are a couple of them, but they're rare. You know, the mouse layer should be thought of as completely separate to the keyboard layer. So you kind of, you know, you can also use that to have two clipboards, which is a little interesting, right? You can have like the inbuilt VI clipboard and then also your like mousing around clipboard, but yeah. Does that make sense? Hopefully.
Yeah, hopefully.
Yeah. Once I get this thing loaded, I'll show you. So, let's see, where were we? Ah, here we go. GitHub Copilot. GitHub Copilot is an extension which utilizes artificial intelligence to provide code completion suggestions and other features. I'm going to try not to be too sarcastic. If the sarcasm gets out of control, just put your hand up, say more, dial it back, and I will attempt to do so. Copilot was trained on everything that appears in public repositories, whether the people who had them there wanted it or not. As a result, it's eerily good, eerily is misspelled, it needs an I, at producing code suggestions given a bit of a starting point. So, obtaining GitHub Copilot. We can install GitHub Copilot as an extension in Visual Studio Code. It is also available for other environments, such as Visual Studio, which I assume you know is different from Visual Studio Code. You guys use Visual Studio for like .NET? Is that the one?
Yeah.
Yeah. Anything else?
ASP.NET.
Yeah.
Oh.
Makes sense. But Microsoft /GitHub charge for Copilot. You can get a 30-day free trial, which is enough to complete the assignment, and you won't be required to use it afterwards. However, it's free so long as you're a student. Don't get used to it, because I'm sure as soon as you're not a student anymore, it won't be free anymore. So it's worth the time and savings to sign up for the free student account. Please do so on your own time. Get the free student account. And I will attempt to get the free instructor account, but for some reason, like I tried that this morning, and like it wanted my location data, and I'm like, why would I need to give you my location for me to sign up for a thing? Microsoft. Ass. All right. Install GitHub Copilot by searching and installing like any other extension. There it is. This is supposed to be Octocat wearing an aviator hat and goggles. You guys know Octocat, right? I put him on the splash page. Yeah, very good. Once you've installed, you'll have to sign into your GitHub account. Boop. Sign in. You'll likely need to complete the sign-in using the browser. Yes, you'll probably... how many of you are using the GitHub Authenticator app, just out of curiosity? Yeah? A couple of people? So GitHub is usually really like a good thing to look at for whatever current, like actual current practice is in security. Because they actually complain about, oh, well, we are phasing out this security model next month, so get on the new one, right? And they can push you around like that because you're developers and not people's grandmothers, right? So, you guys know what the problem is with two-factor authentication through your phone, like through your SMS?
SMS isn't secure.
No, it isn't. Do you know why?
Because it's been around for a long time, but it has a few vulnerabilities and all bad actors that can have access to it if they pay the price for it.
Yes. You're also kind of like, even as compared to like a Wi-Fi network, right? you're talking about a much, much larger area, right? Like, you're talking about the entire area covered by a cell phone tower being your effective range. Because, like, it's kind of a miracle that wireless communication works at all. But, like, you have to keep in mind, when you are, receiving a code and then sending a code, right? That code has been broadcast to every radio tuned to the right frequency in the area around the cell phone tower, right? So it's like not as secure, right? So that's why they're kind of pushing for authenticator apps rather than
Oh,
rather than
that's why.
yeah, that's the reason, right? Two-factor through SMS. Like, it was okay for a little while until everybody started doing it, right? And now it's like, well, you might as well not even bother, Yeah. Any questions about that? Just an interesting little. You looked like you had a comment.
I was trying to remember because I completely forget what it's called, but they had some really big problem where they have really good security to get in, but once you're in, once you're trusted on the network, you can just do whatever you want.
Yeah.
I don't exactly know what that term is referring to.
You should probably ask one of the networking profs.
Alright.
Yeah.
Maybe I will.
So yeah, GitHub wants you to explicitly authorize when things that use GitHub are plugged into your GitHub account, so you'll have to do that. Yes. So, okay. So to test it out, right? If you enter something like the beginning of a function, right? This is a function name describing the function, like what the function is doing. It'll work better on smaller functions, obviously. Some functions are so complicated, you can't really express in 1 or 2 words what the function's actually doing, right? But, it is to an extent nice not to have to do this out by hand, as long as you're checking it for errors. Hitting tab allows you to use the suggestion which has been provided in gray. This is an example in JavaScript. It may produce multiple suggestions. You can hit Alt square brace to scroll through next suggestions. You can go back and forth to see what it gives you. You can see it's slightly different, right? And Control plus arrow to accept a suggestion 1 word at a time, which, if you want to do it up to a certain point, I suppose, add something of your own, then continue on with it. You can hit Control plus Enter to get multiple suggestions presented in a new tab. There you go. You can get multiple suggestions in a new tab. If you want to do a comparison like that. And if you just type in a comment, GitHub Copilot will begin suggesting code that makes sense for that comment. This is an attempt to work around the problem of, well, the function's name is not necessarily a lot of information about the function, right? You can provide more information using the comment. Yes. So, you can also chat with the thing. Chat in the ChatGPT sense by hitting Control I. If you really want to, talk to the thing, if you want to talk to the daemon. And I don't even mean daemon in the sense it's usually used in computers, D-A-E-M-O-N. You guys know what a daemon is, like why that term is used? Do you guys know what Maxwell's daemon is? All right, this is a thing from physics, right? So Maxwell's daemon is a thought experiment where I think the way it works, the internet will correct me. I believe the way that it works is like you have a volume, like a closed volume, right? And you have a gate on one side, and you have a little daemon that sits on the gate and only lets like molecules go out but not in, or something like that. What's the effect? Like, can you like stochastically, will that eventually empty the volume? And that's the type of thought experiment. But like Maxwell's daemon is like, what if we were to impose like some kind of, we can't imagine what the physical process would be by which that would happen, but we can hypothesize it for the purpose of the thought experiment. So like when you think about, like the most common example you'll see is a mailer daemon, right? Like if you ever try to send an email to an email address that doesn't exist, right? Typically you'll get an email in response from a thing called a mailer daemon that will look like garbage output, right? And it's like, basically you've just been handed back an error code, but it's a small autonomous, semi-autonomous program that's just, taking stuff in, and it's like there's a little daemon inside the post office putting letters in slots, right? And that's kind of the sense in which daemon is used most of the time. The other sense in which daemon is used, some people pronounce it daemon, but they're wrong. That's how it's spelt, but not how it's said. Another daemon is the one that routes packets, like to and from the network infrastructure. So like, you'll see references to it every once in a while. If you set up a server that, you've got it running on localhost, like if you read through, you'll see references to like the socket daemon and stuff. So that's kind of the sense in which we usually mean daemon, but here I mean like a metaphysical entity that's bent on human destruction. Yes?
Another small tangent question.
Sure.
Why is it that demon is the correct pronunciation and daemon is not? I just, out of curiosity, I just want to know.
I can't tell you the real reason because I don't know, but I would hypothesize is that it would give people who are strongly Christian some wiggle room to not think they meant that kind of demon.
Oh, okay.
Yeah. Also, maybe it's an older spelling. I'm not sure. It's probably like the Greek spelling or something.
Alright.
All right. The feature is also accessible using the chat bubble icon in the activity bar. Sure. Here we can ask it to make us a JSON array of random data, and it comes up with a pretty good solution. Okay, so this is actually something that I find is like a non-problematic use of the bloody thing. Because like I'm also teaching the database course concurrently this semester, and like if all you need is a whole bunch of random numbers, and it like doesn't matter if the data is authentic, use the random number generator. Why not, right? The thing I said in my database class though is like just make sure to add the columns up because it doesn't do math, right? Talking about ChatGPT particularly in that case, but like it won't do sums and tallies correctly, so you have to go and correct its tallies. But otherwise, it's pretty good at inventing a bunch of data. We can ask it to make a function to add two numbers and return the result. Sure. We can ask it questions about our code. Here we have an incomplete function, and we ask it if the function will run successfully. Will the function run successfully?
Based on the provided code snippet, the function is leap year appears to be valid JavaScript function. However, without the rest of the code, it is difficult to determine if the function will run successfully or not.
That's what I hear every time I hear this chat prompt.
What exactly did AI do to you? Or your career, or something in your life?
It's just like, I kind of view it this way, right? You ever watch, like, okay, how many people have watched SpongeBob SquarePants? Alright? You know the episode of SpongeBob SquarePants where, like, Squidward tries a Krabby Patty for the first time? You guys know that one?
Yeah.
So there's an episode where it's like Squidward, I've never had a Krabby Patty and I don't ever intend to have a Krabby Patty. And then he has one like accidentally and he becomes instantly completely addicted to them. So he ends up like breaking into the Krabby Patty vault and like basically exploding because he eats too many Krabby Patties. And that's how I view most people's reaction to most stimuli that aren't good for them. This is human nature, actually, even though it's expressed through a squid. So basically, it's not good for you, but it's very easy and convenient. So people will gorge themselves on this. Their brains will become flaccid lumps of flesh in their heads that don't actually do anything. And this is ultimately bad for the human species. That's the problem that I have with it. And in fact, you know, we live in a very highly technologicalized society. What this society requires is people with a very high degree of technical expertise and technical acumen in order for the society to even frigging function, right? Like, if people are no longer good at computers because they get the computer to do everything slightly wrong, right? Like, basically the problem I have with AI is that I'm not a transhumanist, right? I do not believe that the algorithm will eventually replace human beings, right? But there are people who believe this, right? There are people who take this almost with religious fervor, that like, oh yeah, like if you read stuff like the president of Google and people of that kind of elevated place in the tech industry, it's not even that they believe that the AI will replace humans. It's that they believe the algorithm is undergoing the process of apotheosis, which is the creation of a god. I'm assuming in the mythological sense, but this is what they actually believe, right? Why do you think they push the stuff, right? Why, like, they push it and they push it and they push it. Why? There's a reason, right? Like, because the stuff's utility does not match the degree to which it's being pushed, right? I'm sure all of you have used the thing before. I'm sure all of you are fully aware of its limitations, right? Good job. Resist the temptation. Like, you're all aware of its limitations. You guys are aware that, like, it's not going to replace programmers anytime soon. Definitely not, right? There are people who believe this is going to be the case, though, right? And, like, basically all of these things about AI kind of boil down to one question. This is how I heard it best expressed. All of these AI optimists, transhumanists who believe that they'll be able to take the algorithm, put it inside a robot, and replace human beings, right? And that perhaps it is the role of the human race to die so that such entities may come into existence, right? But that's how people who are raised on too much science fiction actually think, right? All of it boils down to one question. If you show the thing enough pictures of cats and dogs, does it eventually learn how to recognize an elephant? No. I say no, but I'm not an AI optimist, right? An AI optimist will say, well, if you gave it enough data,
About
What
cats?
kind of data? That's the first thing.
That is
Yeah.
the first thing, absolutely. To understand AI correctly, you must, that's the first step to it. It's only, the bounds of its ability are the bounds of its training data, right? People were very, very optimistic about it, because they thought that it would be able to vastly exceed the bounds of its training data. But this seems to not be the case. The best thing we can do, and the thing that they have done, is try to feed every single piece of information they can possibly find on the whole internet of thing, and see if that makes it into the singularity, right? You guys know what the term the singularity means?
Yeah.
So the singularity is the point at which the machines gain consciousness, self-consciousness, right? The reason they call it a singularity, another way this is theorized is, it's the point at which the machine will be able to improve itself, right? So it's how long does it take to compute the first improvement on itself? 1 day. Well, maybe the improved version can do that in half the time. So a day and a half. Maybe the improved version can have that time again. So basically the degree of improvement you see in the algorithm is exponential off to infinity. And this is the scenario that has everybody very terribly worried. And this is these are, for example, the reason that whatever you think about Elon Musk, one of the projects that he's currently engaged in is trying to wire human brains into computers, Neuralink, right? This is the reason, because I've heard him speak to this before. He believes that it's either synthesis or destruction with the machines, right? We either become part of the machine or we will be superseded and destroyed by the machine, which is, of course, again, transhumanist nonsense, right? Because, how many billions of years did it take to produce organisms as complicated as us, right? It's you vastly underestimate the difficulty involved in producing something tantamount to our complexity, right? And anyway, I'm on a tangent. I might be on an interesting tangent, but I'm on a tangent. So that's the reason I don't like AI. It's because it's built on lies, false promises. It destroys the human ability to reason, and I honestly don't see much benefit derived from all of the destruction, which is kind of I'm only half joking when I call it a demon, because that's how biblical demons operate. They destroy your sanity and they leave you nothing in return. Yeah. So anyway, oh, by the way, today is Michaelmas, so happy Michaelmas, everybody. It's the traditional celebration of the Archangel Michael, who was the angel who actually defeated Satan and cast him into hell. So, since we're on the subject of demons, there you go. But I'm not that religious a guy. You can ask it to fix your code. Okay, if you want to. Ask it to fix your code. Suggests the right fix for extremely simple circumstances that it already has in its data bank. Are we through this yet? All right, we have a longer, more repetitive solution, but still very simple. It can do simple code easily. We can ask it how to improve our code. Here it comes up with one-line solution to the problem when asked, how can I make the function more efficient? Okay, so it makes it into a one-liner. Sure, all right. It's also good for creating unit test cases. Can you create exhaustive unit test cases for the above function? This is a lie. There's no such thing as exhaustive testing because of the state explosion problem. But if you want to pretend that such a thing is possible, I guess the AI will pretend that such a thing is possible as well. This is not exhaustive testing. This is coverage testing. Right? All of you did your testing course. Did they beat into your skulls that exhaustive testing is impossible? Good. I happened to do, that happens to like rub up against stuff that I was doing during my PhD thesis, actually. So, rock, paper, scissors, you know, basically anything that you could go out onto Google and find a pretty decent solution to plagiarize, this thing will plagiarize it for you, no problem. Because that's what it does. It's just, you know, global corporate hyperplagiarism, that's all it is. So, you can display GitHub Copilot if you like by clicking on the Copilot button on the bottom right. There is a button for it if you install the extension. There you go.
Can we delete it? Like just remove the extension entirely?
Well, I mean, you would the option you have would be to not install it in the first place. However, I believe the new Windows laptops are now shipping with a Copilot button on the keyboard. So I am not. This is not a paid sponsorship. This is not a paid sponsorship, but just so you know, I've seen it before. An ad on this thing. There's like such a thing as a Tuxedo laptop, which is built from Linux from the beginning, and you don't have to. Let's see here. I should have just Tuxedo. Yeah, OS laptop. You can buy Tuxedo computers, which are they're Linux computers. They're hella expensive though. So, but yeah, very nice though. It's my yeah, Linux compatible. Oh man. Oh look, assembled in Germany. There you go. The Germans know what they're doing. They're very good at computers. But yes, so you don't actually have to buy a Windows laptop. If you buy a Windows laptop, like the thing I usually do, like I buy a gaming laptop because I need the power, and I don't even let Windows boot. It's like if I have let Windows boot, then the thing has become contaminated. The first thing I have to do is wipe the hard drive, put Linux on it. And then you can rebind that silly Copilot key to whatever you want. Put your own sticker over it. Make it an emoji button. That would be good. That's the stupid AI gives you lots of emojis, right? Oh man. All right. GitHub Copilot is a tool and not replacement for you as a programmer, as much as the people who made it think so. For example, it may produce code which is unsecure. So it's critical that you as the programmer are checking it, checking what it gives you back. This is actually a point that I bring up in my PHP class quite a bit, is like, there is a correct way to do security in PHP, and a lot of the data set that the stupid thing has ingested is like 10 and 15 and 20-year-old blog entries on how to do PHP. So whether it actually gives you current practice on PHP, right? Maybe, maybe not. Actually, have you guys been noticing that like the quality of articles on how to do stuff has been degrading?
Yeah. It's horrible.
Like, for me, it kind of became very pronounced over the summer. Like, I used to basically do this instead of doing man pages, right? Because they're easier to read than man pages, right? It's like, just give me an example of using like SCP or something, right? And it's like, a lot of the time, the code, I've been finding the code doesn't even run or compile or anything. It's like, it's just completely wrong. And it's like, because the blogs have been, probably been generated by a robot, it's like, AI, give me a list of articles that should be on my blog about doing Linux. Okay, now write me those articles, right? It's like, but this is what I think the thing is, what's happened to the poor thing, right? I almost have sympathy for it. It's begun ingesting its own output, right? Which, as a human being, I would highly recommend against ingesting your own output, all right? so basically, any errors that it makes are accumulating over time, right? But what's the problem is that there's so much AI slop now, because like, you know, search engine optimization being what it is, it's like they're probably it seems like most of the hits are like just AI slop articles, right? So this is what I think, this is the era that I think we're in now, right? I think you're gonna have to go back to paying for accurate information.
Yeah, you said this in like first or second class.
Yeah, so I think that we're back to the era where you have to buy a textbook, right? Like, a textbook was written by one guy who knew what he was doing and had an editor, right? So if you want accurate information, like, I think the internet might be broken. I think they may have broken the internet. But yeah, we'll see how things pan out. I don't anticipate it going well for them in the next few years, right? Because this problem is only going to get worse. Question? Answer?
Yeah,
Question?
I'm interested based on your view on AI. What do you think of the Albanian AI minister?
What's his purpose?
Managing government contracts.
That doesn't seem related to AI.
It's an AI system that they put into place like in January.
Oh, some student, I haven't verified this, some student in my other class said that China is now using AI judges in like court cases and stuff.
Oh,
Oh,
no.
I had no idea.
Yeah, so, yeah, no, I think that you're gonna, it'll take a couple of years. Like, the problem is that people at the levels of government that make those kinds of decisions are pretty cozy with the people who are running Google and that type of thing. So they've basically been sold a product, right? It's going to take them some time and hopefully not too many human lives for them to understand the mistake that they've made, and things will eventually revert back to a more sane system. But again, I just hope that I hope the body count isn't too high.
I was just curious.
Because it actually makes a difference whether your healthcare system is run by people, stuff like that.
I can
You know?
imagine.
But, so that's my opinion. It is folly. The world would be running so much better if everybody just listened to me. So this is a true statement. It's generally really good at solving problems that are either in its training set or similar to its training set. I would replace solving problems with looking up solutions to existing problems. It's not as good as problems become more domain specific. So this is where your job is still your job, right? Many of these commonly solved problems you could have gotten a library to do for you anyways, right? Imagine asking the AI to hook into Canvas, right? Yeah, it's not going to do well, right? Because it doesn't know how Canvas works, right? You still have, there's still going to be work for people, don't worry. One of the things that Dave Gilbert says about the whole thing, Dave Gilbert's another professor, he says that, according to studies, use of the AI increases people's feelings of productivity as programmers. You feel like you're being more productive, but then the code has far more bugs than it did before, so you spend much more time debugging. And let me ask you a question. What's the fun part? The writing of the code or the debugging of the code?
Already.
Right. So similarly to in the art world, you're asking the thing to do the fun part so you get to do the miserable part and more of it. That's the sort of thing a daemon does to you, right? So, because in our discipline, it's solving the problem that's the fun part of our jobs, right? Writing the little thing that does the thing, right? It's oh, I got the thing working, right? It's the miserable slog of debugging it once it's half working. That's not the fun part of the job. And unfortunately, most of your job is not the fun part of your job. And that's true for all jobs. Even if you're a clown, like I mean not like in a derogatory sense, but if you're like a children's entertainer, right? It's still work for you, right? Anyway, GitHub Copilot and similar AI tools are relatively new, and the truth is, as a community, we're still learning how to best use them. Controversies. GitHub does not steal your code when you use it, but is it fair that GitHub was trained on open source code that may fall under licenses which restrict its use? No. I'll answer that one for you. Some licenses do not allow for reuse without specific attribution. In fact, that's most of them. If you look at most types of open source licenses, they require attribution of the original source. Is AI attributing the original source? No, not many times, right? Not most of the time. I mean, you can ask it, hey, where did you get this? And it'll lie, so, you know. Yes. If you want your data to be secure, put it on your own hard drive. Thank God this is over. All right. Whew. All right. I apologize. I apologize for that topic. I'm sorry, Kevin. Kevin, if you're watching this, I'm sorry. I had to snark through the whole thing, Kevin.
It needs to be snarked though.
It does. See, this is the thing, right? As software professionals, it's actually our moral responsibility to be snarky about AI. It's our jobs to throw cold water on all of these people who run around saying, "Ooh, we can get AI to do that." It's like, no, no, no. People are good. AI, not good. Learn. You must learn from this. Oh man, I had okay, I'm gonna, personal anecdote, all right? Then we're gonna do this. Personal anecdote. When you get hired full-time to be a professor, they drag you kicking and screaming through this excruciating process of being educated as a post-secondary educator. That you have to go to a lot of like conferences and on your vacation and stuff, and it's, you know, just like the last one was like a happiness coach. There was like a happiness coach speaker. It was the worst thing in the world. But then, you know, you can probably tell I'm a kind of a curmudgeonly guy to begin with. It's like, tell me to be happy? Good grief. Don't you understand how much misery there is in the world? Tell me to be happy. Good grief. People are dying and you're telling me to be happy? And the worst part is, they're not even telling you to be happy. They're trying to teach you to trick yourself into thinking you're happy, which isn't the same thing as being happy. But it passes for being happy among these circles, which are these happiness coach people, right? Anyway, during one of these things, it was like, you know, we were talking about, how do we grade students more efficiently? How do we, you know, make best use of our time? And I'm like, well, I wrote a bash script. I'm the only programmer here. Would you like to see it? I know you won't get much from it, but you know, here you go. So I in the video call, I was like, here's the bash script. You guys won't understand a single sentence of this, but here you go. Take a look. This is a thing that does a lot of tasks for me so that I can spend, you know, like actually a half to a quarter of the time grading that I otherwise would. They were like, this one lady who was like the person in charge of the discussion group was like, could AI do that? And I'm like, no! AI couldn't do that. Would you tell Michelangelo that AI could paint the Sistine Chapel? No! AI couldn't do that. It's much too specific a problem. Yeah, so.
Did you smile?
Did I? Huh?
Did you smile?
Yes, I was smiling while I said that. Yeah. And I didn't say it with quite the same vehemence, you understand. but oh my goodness, but here's the thing, right?
It's already.
Normies, man. What? Oh, is this published? Can you guys get this?
No, like I was saying, you already downloaded it. You just.
Oh, yeah, well, that's because I'm a scatterbrain. Okay, so, Alright, enough AI. Enough! We're gonna learn something useful. Alright, we're going to learn Git. Get out of here.
Honestly, this is kind of cool.
Hmm?
What they call the chat thing.
Yeah?
Yeah.
Uh,
I asked it to create like a simple math and just have like a bunch of math addition thing here going on. Just, interface you get it wrong.
Oh yeah, you're doing the assignment thing, yeah? Yeah, you know. I wouldn't necessarily consider that a very complicated program, though. Yeah.
So AI is bad with specifics. It will overcomplicate it, or.
Well, it depends, right? What it will often do is it'll be pulling from the repositories of like highly professional developers and like insert stuff into your code that you have no idea how that works. Like, you know how a list comprehension works in Python? Yeah, it'll do list comprehensions. You know how regular expressions work? Yeah, a little bit, because we did it in class, right? But people in bloody second semester bloody don't know how to bloody regular expressions. So, yeah. Now, all right, Git! We're not talking about AI. AI doesn't exist for the rest of the class. Try to hold me to that, eh? All right, so, Git. What is Git? Why is Git? Why is Git popular? Why am I expected to know Git? Because industry expects you to know Git. Friggin' right? So, code. Code is hard. Code can be big. Code changes a lot over the lifespan of a project. This is difficult to appreciate if you've never worked on a big project, but let me tell you, just from personal experience, my PhD project was to write a compiler, right, for 2 extremely obscure languages, and then do stuff with it. I ripped the guts out of that thing and wrote entirely new guts for it 4 times before I graduated. It went through many iterations. So, the meme is, should I remove this code or just comment it out until the management changes their mind? And of course, eventually what happens is you get much more commented out code than code, and you can't even interpret the commented out code anymore, so eventually you just have to purge the comments, right? In which case you're losing all the old work. This is a bad way of doing it. Bad. Now, you are one person. Imagine if you had to work with another person, right? Other people are awful most of the time, right? It's awful trying to work with people, right? Especially when you have to worry about race conditions. Have you guys run against race conditions before? Okay. Time for a little bit of on the board bit. You guys all know exactly what I'm talking about because you'll all have experienced this before. So, let's say, just for the sake of argument, I have one file, right? Let's say that this file is called a.txt. Let's say that I have 2 people person B, and person C, right? Narrow face, wide face. Let's say that both person A and person B have some work they need to perform on file A. All right? So what happens? Well, person A gets their copy, or sorry, person B gets a copy of A. Person C gets their copy. Person B modifies their copy. Let's call the modified version AB. Person C modifies their version. Let's say this takes less time, all right? Copy AC. Now here's the problem. We have two copies of this file. What happens when these people try to put their changes back into this file? By the way, this also applies to operations like fopen, fread, fclose, right? Like file system level stuff, right? Let's say that person C or process C, these can also be software processes, right? Writes the changes back. This file contains now AC. Let's say that person B writes their changes back. What is the contents of the file? AB. So the changes made by person or process C are lost. This is bad. You don't know how much work that was. That just got obliterated, right? So this is called a race condition. It's a race in which the slowest person wins, because whoever is the last to write to the file has their changes kept, where everybody else's changes are deleted, overwritten. Does this make sense?
Yeah.
Right. So we all know what a race condition is now. Good. So how does this problem get solved? Within the context of an operating system, the operating system keeps track of who has the file open for writing and will prevent anyone else from opening it while it's open, right? This is called a mutex. Sometimes it's called a semaphore, sometimes it's called a mutex. Mutex is short for mutual exclusion, right? So if, you can prevent this whole situation if you make person or process C wait until B has closed the file before continuing, which, by the way, is why it's so important to remember to close your damn files, right? Because the operating system might be waiting for you to release the resource, right? So that's how things are handled on one computer. But are we doing this on one computer? No, we are doing this on many people's computers, right? So, and we've all been there. It's okay, you can admit it, there's no shame. How many people have managed this with emailing files back and forth? Right? It's like, you send the new copy, this person hasn't seen the new copy, they modify their own copy, suddenly you've got two copies, they email theirs as an attachment, someone has to sort out putting the two of them together. Right? Email is the worst way to do this. But it's the way that everybody does this, because everybody is stupid. So, not intentionally, people aren't intentionally stupid, but, there we go. Man, trying Try to convince people to use Git. This is like active warfare that I have like with other professors in departments. Like, we should just put the midterm on Git. That way we could each work on it. No, it's like, no, we've got to do it with one of the Microsoft collective Word documents. It's like, so that's the other way that you can solve a concurrency problem. That's actually worth noting. Another way that you can solve a concurrency problem like that is to, you have a server, right? The server has the document, and people have to ask the server very nicely for access to the file, right? When you have like the like Google Docs or Microsoft Word equivalent of Google Docs with multiple people's cursors all on the screen, right? It's like, you know what you're doing? You are ajaxing in every character. Right? You are! Well, maybe not every character. Maybe you're sending them in clumps of 4 or something, right? But the more Ajax queries you do, the more up-to-date it looks, right? So that's a lot of network traffic. Maybe I want to edit my own file on my own computer. Thank you very much, right? So, this is bad enough when you've got like a group of 4. Real software projects have sometimes hundreds of people working on them, right? Consider like the credits roll of whatever video game you finished last,
Oh, yeah.
right? That's the number of people who work on, like AAA video games are actually a pretty good indicator of this. And just pay attention to how many programmers there are. But also understand that people who are not programmers still have to contribute to the project, right?
Mm-hmm.
So, people who are not even necessarily good at programming. So how do we develop together? One approach might be to have developers work on separate areas of the code. This works reasonably well when the number of developers is small and when the number of files in the project exceeds the number of developers on that project, right? In practice, very often this is what happens, right? You are responsible for this file, and that file. You are responsible for this one, that one, and that one. As long as you don't edit each other's files, everybody's happy. But, are people terrible?
Yes,
Will people step outside their lane?
yeah.
They absolutely will, even though they shouldn't. So, and the other advantage of doing it that way is like you come to be very familiar with your own little your own couple of files. So it's how much working memory do you have, right? You can't, like when a project becomes large enough, you can't remember everything about the whole thing, right? You have to you silo your brain into a particular region of the project.
Mm-hmm.
So, yes. But the problem is, of course, sooner or later, all of these pieces of code have to work together. This problem, of course, with people is that sooner or later, they have to work together. So, what if and the other problem is, what if multiple people have to work on the same component, right? Some components are quite large and complex, and there's no real good way to break them down into simpler subparts, as much as you try. Some components are very, very important and have to change rapidly. And then there's this problem. The bus problem. Here's the question. What happens to your project if one of your developers is hit by a bus? All right? Not that we are wishing bus hits on anybody. But This is like a problem that a company has to worry about. If any one person in the organization is too essential to its operation, then if the unthinkable happens, you got serious problems, right? You don't want, you know, there's this thing that people make jokes about, right? This sort of coding lore of like, well, if I just write awful, you know, code that nobody can read but myself, P.S. you often can't even read it yourself, then I can never be fired, right? Because, you know, I'm the only person who knows how this code works. I'm the only one who can fix my own broken code, so that's job security, right? I mean, to an extent it's true. It's getting less true all the time. It was most true back in the age of assembly programming, back in the 70s. That's kind of where this lore dates from, right? Because like assembly coding, oh boy, you could write some stuff there. Was like just arcane magic how the stuff would work, and you would be the only person. You hear stories from the 70s, it's like, oh, you know, well, I wrote the program. It's like, oh, I guess we don't need you anymore then. It's like, okay, have fun with that. Like, you know, a month later they come begging back, please come back, we can't make heads or tails of it.
I once heard a joke about an assembly developer where they said, at one point, only me and God understood this code, but now only God knows.
Yes. I've got another joke, kind of in the same lane, but it's a Fortran joke. You guys want to hear my Fortran joke? All right. So in Fortran, all of your variables are floating point data types, unless you specifically declare them integers. But in Fortran, those are called real numbers. So the joke is that God is real unless declared integer. Yes. So, practically speaking, most developers will own certain segments of the code, and developers will work independently on sections of code. These are things that developers do. People tend to work efficiently when they have their own stuff, you know. However, it's often impossible and inadvisable to do this. So, basically, we need something. We need something. We need something to help. And that thing is version control systems. Version control systems. So, basically, overall, the thing that Git does, right? It tracks changes, right? You have a folder, you make it a Git repo, right? It saves the state of the folder when you initialize the Git repo. Any changes that you make to the files, you say, I would like to commit these changes. The Git repo creates a delta, right? It keeps track of what's changed and what hasn't. Well, it keeps track of what has changed and assumes nothing else did, right? And then, using that, right, using that delta, you can completely reconstruct any point in the history of commits, right? You can walk 2 commits back, 3 forward. You can take a look at the very first one. You can take a look at the very last one, right? This is the idea. So, version control systems keep track of different numbered versions of source code files. Developers have the ability to save changes to files and create new versions in the process. Developers can also access older and alternative versions of files. No more saving your files as assignment1_old.js. I mean, effectively, you do sometimes do this, but you know, it's really hard to get away from. But yeah, in theory, you shouldn't have to do that anymore. It's actually like, man, like one of the best things about repos is the protection against your own stupidity in terms of data loss, right? It's like a lot of the time when I saw your name. A lot of the time when you're working on a project, it's like, especially if you're in a Linux environment, it's like, oh shoot, did I just destroy everything in the file but not the file itself, so it didn't get sent to the recycle bin? By the way, I'm pretty sure the recycle bin only works if you're not in terminal mode. Anyway, that might not be true. Yeah, that's probably not true. But anyway, there is definitely ways to destroy files, right, permanently and in one line. What if you could just wave your magic wand and say, git revert very important data file I just deleted, and it springs back to life as if nothing happened, right? Useful. So, developers are able to access shared repositories of files rather than sending zip folders back and forth. That's the other thing. So, okay. One of the things we're going to have to understand fairly quickly is the difference between Git and GitHub, right? GitHub is a hub for Git. Git is the underlying program, right? Today we are going to be learning how Git works. How Git works is how GitHub repositories work, right? But you've got a nice fancy, web interface for it, and you have collaboration tools, right? But in terms of fundamentals, Git is the program that powers GitHub, as well as Bitbucket, GitLab, all of these different things, right? Make sense? So, earlier version control systems included revision control systems and concurrent version systems. Yes, historically speaking. These were largely superseded by Subversion, which added additional features and improvements. So RCS and CVS are old programs. These were merged into a thing called SVN, Subversion, when I was but a lad doing a When I was but a lad doing my PhD, I didn't actually have a Git repository. I had an SVN repository. That's how old I am. I am 37. Git is now the industry standard version control system. Pretty much everyone uses Git. It has won the battle. Pretty much nobody uses anything else these days. You can tell that this was even true as of, 2011, right? So Git has been the market dominator for a period of 15 years now. The other competitors were SVN, Mercurial, Perforce, and CVS, which is even older. So, here's another one. This is slightly newer data. Interest over time, Google Trends. How they're mentioning, how they're marking interest might be Google searches. Man, it just occurred to me how much, AI is going to screw up all their statistics taking on, searches and stuff. Interesting. Anyway, Apache, Azure, Visual Studio, and concurrent version CVS. This graph goes back all the way to 2004. It's a couple of years old, more in history than that one. So, yes, this is what winning looks like. All right? Y'all remember the client-server model?
Possibly.
Possibly. Previous version control systems followed the client-server model, right? An SVN repository, you have the server, you sync yourself with the server, right? Developers on client machines check out code from the server and check the code back into the server. Git is a distributed version control system where each developer has a fully functioning repository on their own system. So, client server, right? Main repository is kept on the server. Clients all have their own local copy, but they all have to interact with the central server in order to get their files. This is the same diagram in a different way. Distributed model. Every single client has their own fully functioning repo, so if one node in the network gets taken out, so what? You've got all these other copies, right? Okay, I've got just a little story about client server versus distributed, and then we'll break for the break, I think. Okay. So Dark Souls 1. How many people have played it?
Me too.
Yeah. There we go. I love the praise the sun.
Oh, yes.
Yes. So Dark Souls 1, the multiplayer in it was fairly remarkable for its time. I know everybody knows that Dark Souls didn't, like, it was based on Demon Souls and all the rest of it, but let's just talk about Dark Souls, right? Not to bring demons up again, but so Dark Souls 1, the network multiplayer for Dark Souls 1 works on a distributed model rather than a client-server model. You guys may not have been aware of this. So it was kind of interesting. When Dark Souls 3 came out, Hasbro, is it, that makes that, or licenses it? Whoever they are. They decided, you know what, we're really not interested in supporting the server cost for Dark Souls 1 anymore, so we're just gonna kill the server. Sorry guys, go get the new one, right? And then everybody in the Dark Souls 1 community was like, you don't understand. Dark Souls 1 is my life. I cannot live without this game. You are literally killing me. So this is what they did. They wrote a very small patch, a couple of lines of code. You install that patch on the original Dark Souls 1 software and boom, you got your multiplayer back. And the reason is, it's a distributed multiplayer system. It's a decentralized network of nodes. So you can't shut Dark Souls 1 down because everybody has the ability, like, as long as there are still 2 people playing Dark Souls with that patch, right? They can connect to each other because it's been decentralized, right? Yeah, that's a big. There are probably other games that do multiplayer that way. One of the reasons that you do that way is because it downloads the server costs to the users rather than having to pay for a lot of server upkeep. So yeah, interesting, right? So yeah, so that's the reason that there's just a very quick patch to get Dark Souls 1 back up on the multiplayer, but like, try doing that with Splatoon, right? Good luck. I don't know, maybe they still run that server, probably not. You probably also like can't connect to the Wii Shop anymore or anything like that. But anyway, digital games are a mistake. Buy your games on cartridges. All right. Any questions? Comments? Anything? All right. Yes. Sorry, oh yeah, I'm sorry, you've been
I
waiting
had
for a while.
comment, but
Sorry.
it's like, I was just like, okay, I guess you forgot.
What did I forget?
Well, when you were talking about version control, I wanted to make a comment saying that me and my partner, we were doing a game demo, and all of our, like, in Unity, all we just did is like, oh, this is final underscore. Oh, no, we have one last thing, no, final underscore 3.
Yes.
Until it just continued.
Yeah, it's hell, right?
No, but I mean, like, it's two people, so it wasn't that bad. It's like, we knew what we were doing.
Yeah, but imagine if you had, like, 8 times the number of people,
Yeah,
right?
it'd be hell.
Yeah,
There's no way.
yeah, exactly. Like, you've heard of games that get stuck in development hell? You've heard of games like this? Like Duke Nukem 3D or something was in development for 15 years, stuff like that.
Oh my god.
Yeah, Metroid Prime 4. Anybody remember that? Yeah? Yeah, there are games that are in development for over a decade. And I have to think that the reason is in the back end, because they've been passing the project around in email attachments or something. Alright, well, let's have our break. Please be ready to resume at 5:34, and we'll continue talking about Git. We haven't actually talked about how to use it yet. We'll get to that after the break. Because just to hell with Central Europe,
Yeah,
man.
no.
It's impossible. That's going to be really funny out of context. I'm talking about a video game. It's impossible to make any, don't fight a land war in Asia either. Yeah, and whatever you do, don't engage the Russians in a land war in Asia. That's really good advice. Okay, all right. Class. There you go. All right. I thought I turned you on. There we go. I had a realization with a creeping sense of horror. What happens if the bulb goes in the projector?
Yeah, over.
I mean, we're already kind of screwed because it's after hours, but who are you gonna call?
Because we have no more support staff, right?
Yeah, because IT's on strike, so who's gonna replace the projector bulb if the projector bulb goes?
I mean, worst case scenario, we still have our, we could follow along.
Give the projector company a call.
I mean, yes and no. The answer is, I think they have 4 co-op students, that are currently the IT department. So,
For what school? Our own school, or?
yeah, here at proud, good Mohawk College. Okay, all right. Git. So, in practice, for example, with GitHub, although it is true that every Git repo among every person who has one is an independently functioning repo and can reinstantiate all of the rest of them if necessary, you do traditionally have a server which coordinates everything because that's just a useful way to do things. So it's distributed, but it's also centralized. I won't say it's the best of both, but best of both worlds. But so, anybody know who this guy is? My man Linus Torvalds, the most famous Finn. So, this guy is the guy who invented Linux. Alright? His name is Linus Torvalds. He is Finnish. So when I say he invented Linux, he created the Linux kernel. He didn't make all of it, but you know, every time when I install Linux on a new laptop, and it's quite a new laptop, and you know the drivers aren't quite there, right? And then I get a patch, I get a kernel update, and suddenly everything works. I'm like, thank you, Linus, because he still does a lot of like active development on the driver level stuff. So, so Linus, our good friend Linus, had a reputation for being an unpleasant person to work with. British slang for an unpleasant person is a git. So he named the software which he wrote to make people want to be friends with him, Git. Oh, and by the way, you guys know what Linux, where the name Linux comes from? It's Linus Unix, Linux. So this guy has both Git and Linux named after himself, which is pretty impressive. So, getting started with Git. All right, everyone. Do you have your Linux Mint images loaded and ready? Please get them ready now if they are not already. It's time to bash. You guys can tell this is my favorite class, right? Databases is deadly boring. Oh, another piece of advice for your videos, please click away the side panel that tells you the stuff from the VM. Okay, I don't need to see that. Alright, so, Git. Help! You just typed Git, so you clearly need help. There you go. Git is a program pre-installed, so you don't have to install it, but it's easy enough to do so. You would just say sudo apt install git, and that's how you would get it. Very good. So, there are GUI interfaces. You can get GitHub Desktop is, I believe, the name of the application. But we're going to be using the command line version because you can't script the desktop environment. Well, I mean, I think technically you can, but... So, in general, it's okay to use the GUI way of doing things, but you should learn to use the command line as that will be expected of you later, right? You'll find some programmers may look down on this. Your professor is one of them. If you're going to be a professional software developer, it's expected that you understand command line, and that's kind of the purpose of this class. So, you know, if you wanted to flub around with a bunch of pretty pictures and boxes, you should go take UI UX. Which I think you had to. Did you guys have to take UI UX?
No.
Oh,
That's
that's after your time. They introduced that as a required course, I think, like immediately after you guys. Yeah. So. I mean, from what I hear, it's not very good, so you didn't miss much. I heard one of the students in the Game Dev Club guy complaining about it, saying they were trying to teach you to have empathy with the user. They were trying to teach user empathy. And my response to that was, or no, it was client empathy. Client empathy. And my response to that was, no, never trust the client.
Exactly.
You never empathize with them. I would have to trust them first. Good grief. So anyway, so Git repositories store changes to files. We create a repository by initializing a repository. We use the command git init to initialize a repository, but it's also kind of funny. It's like git init, just get in it, right? Get into it. It's a anyway. So a couple of important things to understand about Git repositories. A repository is a directory with some stuff in it. Alright? We'll make one, and I will show you. So, make directory, baby's first repo. There we go. CD into that directory. We are now in the directory. Oh, let me increase the size. Yikes. There. Can you see this at the back? Good. So, we have our folder. It's important to be inside of the folder that you want to make into a repo. Git init. Right? Using master as the name for this initial branch. This default branch name, int, is subject to change. You can configure it, blah, 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 blah. Alright. Initialized empty Git repository in home, tooltime, baby's first repo, dot git. Question.
Before / after the directory's name, is it optional?
Sorry, the forward slash where?
After the directory name. Baby's first, when we see.
Oh, like here, you mean?
No, like when you change directory to baby's first repo, you use the
Oh, here?
first. Yeah.
Oh, yeah.
Did you
it's-
have to do that?
No, stop. It's, in fact, I don't think I did that at all. I think that was part of the autocomplete. Let me just check this. CD. Yeah, that's part of the autocomplete.
Oh,
So,
autocomplete is tab.
autocomplete is tab, yes. Scrolling through previous commands is up and down.
Yeah.
But yeah, if you remove the slash, it still works. So, like, putting a slash at the end of it is like Linux speak for this is a directory.
Oh yeah,
Right.
I remember that.
Yeah. So, yeah, very good. Technically, if you write it that way, then you can just concatenate it with a file name and it will work. Otherwise, you'd have to insert the slash. So that's probably the reason, but it's not like a best reason, but anyway. So we have a Git repo. There is nothing particular about the Git repo that makes you think it's a Git repo, right? It just looks like a folder. In fact, it doesn't look like it has anything in it, but the thing that makes it a Git repo, ls-a, for all, you will see we have the hidden folder, hidden directory, .git. This is where all of the Git information is stored. cd.git. Things aren't hidden once you're inside of the hidden directory. So you can see we have all kinds of interesting things. Branches, config, description, head, hooks, info, objects, refs. A lot of stuff that we don't have to really worry about. That's these are the internal details of how Git stores the information for the Git repository. But just, understand that it is not magic, right? And it's also understand that there's no hidden, there's no folder in the operating system which is keeping track of all of this information about all of these repos, right? It is stored in the repo itself. It's stored in the directory itself. So you can effectively ungit a directory by deleting .git. Turns it back into a non-git directory, right? Now, I wouldn't recommend doing it that way. I would recommend finding the correct git command to do that. You don't know what else might be going on in the background, but in general, that will work. Make sense? Good. So, we have a repo. Yes. So, except they missed one, right? There's one up here that you have to do before you can commit. But, yes. So this is how it works. Now that we've initialized the repository, we just do our work, right? We create our files, we edit our Java assignment, or whatever we're working on. In our case, let's just make a few text files, right? I'm even going to try using Vim. Let's do Vim file1.txt. Oh, okay, sudo add. Fine. There we go. Failed to patch. Really? Are you still going to work though? That's the question. Oh, I didn't update. There we go. There we go. There we go. Insert. I am the very model. Oh, get out of here. Model of a modern major general. I'm formation, vegetable, animal, and mineral. And escape, colon, right quit. There we go. Cat file 1. There we go. A file with some text. Question?
What was the update command you ran to fix the E unable to fetch some archives?
Oh, very good. It's just sudo apt update.
Do you have to always run that command before installing Vim?
No. You have to run this command, sudo apt update, before you try to download the software. Actually, apt will add this program to your update manager's sort of list of things it looks for. And anytime an update for Vim is available, you'll get a little notification there and you can update it. So after the point of initial installation, you don't have to worry about apt anymore. All right, we good? So far so good? Need a moment further?
Yeah. How do we save and exit the?
In Vim, to save, press escape, colon, W write for save the file, and Q for quit the program. You can also do those separately if you wish, or you can do it in one step like I did.
Escape colon W.
Q.
Q. And enter. Done. And enter.
And enter, yeah. And then you can verify that the file was written by
Cat.
cat. So far so good? Alright, we have a file with changes. So this is the workflow. The first thing that we have to do add the file to the repository. Git add file1.txt. Now, most of the time, you're not going to want to do this to each file individually, right? So, this is recursive. If you use dot, can anybody remind us what just a dot hanging out by itself does?
Just the context of the directory that you're in.
The context of the directory that you're in, yes. This is a shortcut for the current working directory. And because it's recursive, it'll do this directory and all subdirectories. Now, this does mean that if you want to, if you want to add stuff, basically you should almost always be doing this from the root folder of your repo, right? Otherwise, you're only adding changes from like where you are and down. So if you're already in a subdirectory, changes that are above you won't be, new files won't be added, right? So do this, do this from the top level of the directory wherever possible, until you've become sufficiently skilled with it to understand what you're doing and what you're not doing. All right? Git add dot. Fail this operation. What? Oh, what are you doing to me? Oh wait, I'm in. Where am I?
Can I get it for?
Whack, whack, whack. All right.
We have the CD into.
Yeah. All right. So let me move the stupid thing from .git / file1 to here. There we go. Now it's there. Now git add dot. There we go. Very good.
So dot means go up one direction.
Correct. Yes. Good. Now, it might be useful to take a look at our status. Git status shows you all of the files which have been staged for committing. It also tells you, what commit you're on. And I believe we'll try this out again once we've done this first commit, baby's first commit. I believe it also shows you what changes have been made to the repo since the last commit as well. But if it's not that command, it's a slightly different one. But here we go. Git commit. When I hit git commit, git commit, I'm brought to Nano. Please enter the commit message for your changes. Line starting with a thing will be ignored and end up blah 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 blah. So basically, this is how Git commits work. You must provide a commit message, right? You must do it. It's not optional. If you don't provide it, it'll say, hey, you just forgot to do that, right? You weren't trying to commit anything without documenting what you were doing, right? So, you can say, baby's first commit. Save, exit. There you go. And we have made our commit. Very good. On a local repository, that's it. If you are synchronizing this repository with something like GitHub, there's one further step. Git push. If I enter this, it'll complain that there's no remote repository. Yeah, no configured push destination. Right? Once we set things up with GitHub, though, it will have a configured push destination, so you'll be able to push it to the push it to GitHub. Make sense? So far so good? Alright. So that is how you commit files to the repository. Alright, any questions?
So what? Okay, git add, git commits, git push. Okay, I know commit means put it in our repository that we created, and then push is if we have like a.
Remote repository. Yeah.
So what did add do again?
So let me show you. I'll do it by example, and then you had a question too.
Yeah, just offer identity and when I want to
How do you send this message?
Yeah, just do as it says. It's really good at telling you what it needs done. Yeah. So, let's add a new file, different file. We'll do the process again. File2.txt. 11, oh no. Right quit. Oh, I saved a bad character in there. There we go. So, we have file 2. Git status. There you go. Git status is now reporting I have an untracked file. This must be added. Use git add file to include in what will be committed. See, one of the things that's really nice about Git is it gives you very good information, right? You can almost like survive blindly on the output that it's giving you. If you just do as it says, you'll get there most of the time, right? But, of course, we have higher aspirations in this classroom. We aspire to actually know how the thing works. So, nothing added to commit, but untracked files present. So, git add dot. Showing git status again, you'll see that file 2 has moved from being an untracked file to a tracked file. That is the purpose of git add. Git commit. You can use the M flag to specify a message. Second commit. There you go. Now we've tracked the change that we just made. Here's another one for you. Adding modifications. Let's edit file1.txt. Every time. So as you can see, I have added 2 more lines to the song. These changes need to be tracked. If we say git status, there we go, you'll see that git add is also used not only to add new files to the repository, but when we modify the file, we also add it git add in order to add it to the repository. Make sense? So this is very convenient because it means that all you have to do is git add dot before you commit git status. It's now a change to be committed. Git commit added 2 lines. I almost did the thing. This is a local repo. For me, it's like so automatic, you know. I actually use this software like friggin' all the time. Like when I write like a midterm, I'm using like all of my midterm questions are in their own text files, and I'm using Git to like track changes and do stuff. This is a thing I actually do. I can't show you from this semester's tests, but ask me sometime and I'll show you. I'll also show you the bash script for like midterm generation. But anyway, yeah, I know I make things too complicated. So far so good?
Yeah. So git add the containing folder, and then just git commit and git push.
Give it an informative message, yes.
Oh yeah.
And also, yeah, git push
Is for
when it has a remote repository, which it almost always will, right? But not in this case. Yeah. Like most of the time, you're not going to, like if you're making a repo on GitHub, you don't use git commit, right? You go through into GitHub, use their create new repository dialog, create the repository, then check the repository out onto your local machine. It's a process we'll go over, but like git init is not something you will normally do, right? But it's necessary for us to do the basics. Sound good? Excellent. So, yes, showed you that. Showed you that. Anything? Yes? So, you can add a file, you could add multiple files, or you could add all files. Log messages are important. They should describe what changes are being committed to the repository. So basically, like, don't do what I do, which is like hook certain of your Git repos up to like a bash script and just have it use like the message auto commit. Don't do that. Don't do what I do. On the subject of git commit messages, don't do this. All right? Try to resist the urge, right? Your messages should be informative. They should describe the work that you've done between this commit and the last one. And most particularly, try to keep them short, right? If you've written a whole English sentence, you're probably doing it wrong, right? Also, I've heard it said that like you should use like present tense because it's simpler. But as a grammarian, I must object to this stance. Use correct, whatever language you're using, use it correctly wherever you use it. But and certainly don't do that. That's the worst. Don't do that. Very good. good, did that, yes. Okay. So now we have a couple of commits under our belts now. We can take a look at the log. So, git log. This is our history of commits. You will notice they are given an author. This comes into it a lot more when you're working with other people on a distributed repository. A date, time, and the commit message. You also have this long thing. This is your commits serial code, serial number, right? These are automatically generated, and you can use these to refer to historical commits. There are shorter ways of doing this. Thank God. Okay, you want another fun anecdote? All right, you guys love my anecdotes, right? I've been using Git repositories to manage content for courses for quite some time. Back when I worked at the university, I was using them not only to manage like my course materials, but also to as a way of distributing course materials to my teaching assistants. Because when I was at the university, you get TAs, right? You're more expected to develop the courses and manage TAs who do a lot of marking and some of the teaching. That's kind of the structure, right? Anybody ever been to a university? Taken university courses? Yeah, you guys know what I'm talking about. TAs do pull a lot of the weight, right? Well, the one semester I was doing this, and one of the things that we were keeping there was the sometimes when auto grading software existed for assignments, that's where it would be and that sort of thing. I had someone, and I forget the particular details, but we had a grade book where a lot of students' grades were stored and some metadata that was necessary that couldn't be put into the grade system through the learning management system. I think something like output of the auto grader or something like that. And the TAs went on strike. And one person, I guess a disgruntled employee, didn't delete it. They vandalized it. They took the file and they messed the data up in it as they were going on strike, as they were going out. And it was you are an idiot. Because I know who you are and when you did that. And it's a Git repo. I can literally just revert to the last commit you made, you nincompoop. But yeah, that's a thing where Git actually saved my bacon once, because I had a TA who attempted vandalizing my grade book, and this saved my ass. So yeah, I recommend it.
What did you do to him?
Well, it's interesting actually, because it's really hard to get someone fired, I think this was a number of years ago. I think what happened was they just didn't come back after the strike ended. They just didn't come back, and certain categories of TAs they feel entitled to their positions because they're entitled to their positions in the contract of when you're a grad student you're entitled to get a couple of TA positions to put you through, but really it's we're going to use you as cheap labor to run courses. And so I always found that undergraduate TAs were way higher quality than grad student TAs, because grad TAs were just they were there to tick a box type thing, whereas the undergrads were like, well, this is what I'm gonna do to like get a job and stuff, is like use this as experience, so I wanna do a good job. Not always, but often that was the case with undergraduate TAs, so yeah, like I think someone just like kind of didn't return after the strike was over, and it's like, I can't fire you, I have no way to discipline you in any way, I can't do anything. I was powerless. All I had was the ability to get my stuff back, which was all I needed, because, you know, when a person does that sort of thing, they were never much help to begin with, right? But, yeah, it's kind of funny, during that particular strike, I had one TA scab, and it was like, well, you didn't do one lick of work before the strike, and you certainly didn't do any work during the strike, and you didn't do any work after the strike. So it's like, you know, I had one TA, but during that strike, that was an interesting one, because I had like 14 TAs for among 3 different courses. So like taking away my TAs was the equivalent of taking away like 4 full-time employees. Because they're like 10 hours a week for those positions, but anyway, that was awful. I'm sorry. But yeah, the moral of the story is, if you keep a log of things, it means that, you know, if you keep a commit history, you can reverse changes, and that's good, because sometimes changes happen and you're like, oh shoot, that's a change. Okay. And it's not always because of your own stupidity. Sometimes it's just malice, right? So you see why I say people suck, you know? Like, I have reason to say people suck. Present company excluded, of course. So, anyway, Git log shows you all of your commits in your repo. So, yes, we did that, yes, now yes. So, you'll notice something, right? Head master. So, GitHub calls this main, more inclusive language. So, the main branch is the main branch, right? We haven't really talked about branching just yet. You don't start off with branching. Branching is something you opt into by using git branch, right? So the main branch is just this line of commits, right? It's your linear line of commits that we've been doing so far, right? Oop. Get away, Firefox. Get out. Go away. Nobody likes you, Firefox. I mean, wait. Anybody use Firefox in here?
I do the test.
Yeah?
I do just test local host stuff.
Yeah? Is there a reason you prefer Firefox?
It was for privacy reasons, but they changed their whole terms of service, and now I just kind of get used to it.
Well, that's how they get you, you know? Favorable terms until they decide it's not favorable terms anymore. The internet sucks, man. So we know what, hopefully, it's kind of difficult to understand what the main branch is without having any other branches to talk about. It only kind of makes sense in that context. But head should be fairly evident. It's the most recent commit that's been made in your branch, right? So the head of the main branch is where you are actively working, unless you're going through the history, stuff like that. Make sense? Oh, questions? Okay, good. All right. So, repositories are split into branches. The default branch of all repositories when they are created is the main branch. The main branch is the mainline branch. In practice, it is expected to be a working copy of the program. So this is important. Don't break the main branch, okay? When you are working on something, the main branch is that is at all times the sort of forward-facing, this is the version that works, here use this one version of the program, right? If it's broken, because you've been pushing, you've just been using the main branch as if it were any other branch, and you've been doing active development on it, and you make intermediate commits, which, by the way, is a thing you should definitely do. Like, as you're working on stuff, make many commits, right? But if you're doing that in main, it means that, the question you have to ask yourself is, if some poor user of this program wants to download it from GitHub and use it, is main broken right now? Have I broken main? Are they going to get a broken, syntax error-ridden copy of my program? If so, the work you're doing should not go in main. It should go in your own branch that's being used for something, whatever you're developing, right? Make sense? Question?
Given your example that you did before, is it the equivalent of, because you had the example with the A file, and then they all both make a copy of their file, are branches the equivalent of just what they were working on at that time?
Let's go back to the diagram. So, this is what happens, right? We no longer are talking about individual files. We are now talking about commits in a commit history, right? So, let's say we have a commit here. Let's say that person B, and we have also person C, there we go. So file A will be contained in this commit, right? But we're not interested in just a single file anymore. We want the whole thing, right? We want the whole project. This will be our main branch. This is what happens. Whether or not it's simultaneous, by simultaneous I mean whether or not there are any commits in between these, right? Person B creates a new branch, maybe calls it B_dev, right? Starts working on it. Maybe there's even another commit in main, right? Person C branches the repository, right? Now, you can have as many commits on these branches as you want. You work on them to your heart's content. That's evenly spaced. That's more evenly spaced, okay? Now, when you're finished, you have to do the dreaded git merge. All right? Git merge. All right? Then, when this guy is done, they merge as well. After, like this, can sometimes be done automatically. It will do it automatically to the extent possible. It is most possible when like actually this one would probably be fine. It's this one that's gonna get tricky. If person B and person C have been working on different files, there's no issue, no conflicts arise. If they're working on the same files, it's possible that no conflicts will arise. If all that's been done is you've added or removed lines from the file, you won't run into conflicts. It'll just, add or delete the lines as necessary. If person B and person C have modified the same lines of code, you require a human arbitrator to decide which lines of code are the ones to keep, or can I come up with some, you have to look at the code and decide, I've got one version of this, I've got another version of this, which one is the correct version, right? How do I merge these, so to speak? And the great thing about it is that Git puts that responsibility on the person who's merging the branch. And you have to complete that work before you are, you have made a valid commit into main, right? So that means when you're merging back into main, it's your job to make sure you're not breaking main as you're doing so, right? Making sure that you're merging all of your changes into everything else in a way that's harmonious, right? And yeah, does that make sense? This is the concept of branching. This is how Git solves this problem, right? Basically, it makes it the responsibility of the branch, the person with the branch, to make sure they're not overwriting things, right? And hopefully, if both these people are intelligent developers who are not being intentionally destructive, everything's fine. Even if they are being intentionally destructive, you can always go back in the history to the previous point before the merge. Does that make sense? Very good. So you can see how that solves problems, right? The issue is that there's a kind of an irreducible problem at play here, right? You can automate away a lot of the problem of trying to merge two projects together. The projects will be 99% the same in both cases anyways. Even within a file you can do it, but there is a point at which, code must be merged into code. And the job of Git is to highlight to you where that has to occur. And so you go in, you make your edits, you move on, you move along, you move on with your life. Does that make sense?
For a second. When I looked up, it was 7:23, and then I looked.
Oh, don't. That thing lies. Look, see, it just did it again. No. Sorry. That is accurately measuring the time. We are actually traveling. This wing of the building travels through time.
7:22 when I looked up for a second.
Yeah.
And then it's 6:23.
6:26, 24. Yeah.
Use your own local timepieces. All right. So, what are branches for? Normally, the language that's used is feature. You're adding a feature, right? Now, a feature doesn't have to be, what you may think of when you think of a top-level feature in something, right? It doesn't have to be DLC for a strategy game or something, right? A feature can be small, right? But, that's kind of how you break it up. when you're trying to add some discrete piece of functionality, that is a feature, you open a branch. You do your development work. When you're finished, you merge that branch back in, and your feature is added to the program. Make sense? Good. So this is, yep, not a very, I don't think that's a very useful diagram. Branches! So, two very important commands. Git branch creates a new branch. Git switch switches to the branch with branch name. So basically, when you create a branch, it doesn't automatically put you in the branch, right? Although perhaps I should back up a little bit. So when you are working with Git repositories, there is a concept very similar to the concept of the working directory, right? You have your working branch. Changes that you make are made in the working branch, right? So you must be aware of which branch you are in before you make a lot of modifications. This is why one of the things that Git status gives you is what branch you're in, right? So let's make a branch. Git branch dev1. There we go. Git log. Yeah. Git status. Yeah. Git branches. Is that the, how do you view branches? I forgot. It must be in the notes, right?
Just git branch, prints all the branches.
Oh yeah, that sounds right. Yeah, there you go. Thank you. So yes, Git branch shows you all of the branches. We now have the main branch and we have dev1. Very good. If we make a modification, well, first we have to switch. Git switch to dev1. There we go. Git status on branch dev1. Question?
Is there a difference between git switch and git checkout?
I think checkout is a more general tool. You can use it to go back in the history. I believe git switch is it's an abbreviated form that just brings you to the head of that branch.
Okay.
So let's make a modification to the file. File1.txt. I have added a couple of lines. Oh. There we go. I don't know why they would put a black bar on the top of it, you know? Like, just, why? Anyway, I have added a couple of lines, but we are in the branch. Say, I would guess, quit. There we go. Cat file1. Cat file1. We get all three verses of our song. Git switch git switch main. There we go, switched to branch. There we go. Git, or not git, cat file 1. So, not what we expected, right? So, understand, switching branches does not change the contents of the local files, right? So, this might be a difference with checkout as well. So git switch, and switch back to dev1, and commit these changes. Git add, git commit, git push. Oh, I'm sorry. Ha! I did it. I told you. It's muscle memory, man. So, there we go. So now you can see that our log has become a little bit more complicated. Our head is now in dev1. You can see that this is the head of main, right? It's labeled. So, there you go. So the checkout operation switches you, like it loads up the specified commit, right? So when I check out master and I ask for the status of file 1, I get the old version, right? The old version. If I git checkout dev1 cat file1.txt, you can see checking out the branch, I now have all of this, I have the new stuff that I added inside of that branch. So you can navigate back and forth between the different branches, seeing the states of things in those branches, right? But this is not something that switch gets you. So, yes, yes. So, yes. So, here we go. Here's something. If we switch back into the main branch, git log, you may notice that commits which are in dev1 don't appear, right? So when you ask for git log, it's only going to give you the line of commits which led you to the point you are in, right? So, going back to this diagram, right? If I'm on branch 1, I see all of these commits, right? If I'm on branch 2, I see all of these commits. If I'm in main, all of these commits, right? Make sense? Unless, yeah. unless you specify the all flag. Now, you'll find a lot of sort of more recent a lot of more recent command line programs will use this type of notation for flags. These can often be condensed to one-letter flags, but it's kind of becoming increasingly common to provide an option with 2 dashes and like the whole word. So yeah, it's a little bit more readable, right? So git log all shows you the entire commit history. Yes. Yes. So. So. Now, at the moment we're in this situation. Right? We've pulled a branch off, we've made a commit there. We've made no commits here. Merging this back in is trivial. Right? There's nothing to merge. Right? In fact, if you look at the history just in terms of commits, like this doesn't even technically exist, right? There's no commits on that branch. It does still, like it's still good to use branches even if this is how much you're doing, because this will preserve main for people who are trying to download it while you're working on stuff, right? Still good to do this even if there are no commits going on. But basically things get a little bit more interesting once once we have another commit right here. So we're going to make one, okay? So. What branch are we on? We're on master. So, git, let's vim file 1.txt, insert mode, So now I have two versions of file 1. The one residing in the branch has one version for the third verse. The one residing in this branch has a different version for the third verse. All right? Now, shall we try to merge them? Well, let me see if I'm not jumping ahead too much in the... Yeah, okay. There's a couple of things, then we'll try to merge them. So, let's do git log all graph. Did I get the same thing? Let's see here. maybe switch to, let me switch to, git checkout dev1. Oh, I didn't commit, that'd be the reason. See, isn't it nice that it warns you? You know? So, git add dot, git commit, and changes. Git push. No! I almost did it. So, now we take a look at the log. There we go. So, you see we've got the branch, oh, branched off, one here, one there. If you reverse this to look the other way, that's what that is, right? Now, you might be saying to yourself, that's kind of clunky to look at. Can you improve it? Oh, come on. It's later on. I don't really, all right. One line. Give me the one-line one. Come on. Come on. Where is it?
Graph visualization.
Shoot. All right. Anyway, that's okay. So, all right. Now we merge.
It's git log, all and graph.
All in what?
And graph. It's in the PDF, just graph.
Oh.
Just graph.
Oh no, like there's a command that'll condense each commit message to like one line, so it shows the graph a lot more nicely. We'll get there. So let us attempt. Da 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 dum, da 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 dum, da 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 dum. We are on. Okay, so it's git checkout. Dev _1. There we go. Git merge. Wait. Oh, wait. Where are you supposed to be when you start that? While on master. Yeah, okay. So okay. Checkout master. There we go. And git merge dev1. Are you ready? This is a little bit risky. Are you prepared? Dun 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 boom. Merge conflict in file 1. Automatic merge failed. Fix conflicts and then commit the result. Okay. Shall we see what it's done to our poor file? Oh! So, it tells you what branch has what, but you can see that it is actually placed text in the file, right? These partitions, which were the same in both cases, it's like, yeah, okay, sure, it's the same in both cases. But this one and this one, these are the same ones, right? So, we have to fix that manually, right? And I'm sorry, but I know, I'm sorry. I just want a mouse for a minute. I know. There we go. So this has actually been placed into the text of a file. If you commit it like this, that's obviously not correct syntax in any language, so you're breaking it, right? So the idea is you're supposed to look at it, you're supposed to read it, scratch your chin and say, what was meant by these things? How can I fix this? Well, of course, if you know the modern Major General song, you know that this verse is supposed to come first, and this verse is supposed to come afterwards. And then you delete that, save the file, right? Cat file1. There you go. We no longer have the awful merge conflict bar in there. git add, git commit, fixed merge conflict, git push. No! So close! Every time! Alright. And there you go. Fixed merge conflict. Now, something interesting has happened to the graph. See? Now our branch is merged, our branch has closed, we can continue. Changes have been added back into main. How's that? Is that good? Make sense? So, let me ask you a slightly related question. Do you feel as if your knowledge of Git is improving?
Yeah.
Yes,
Okay. You're finding this to be useful?
yes.
Good. Alright, because like, it's actually like a little bit complicated how the thing works, and like, it's not obvious what branching is actually doing unless you've been instructed. This is like the idea behind this course is like, people are kind of just expected to pick that up, but like, I don't know how you would just pick that up, you know? You should, like, you either get it from a class like this or a textbook, right? So, yeah. Ooh, on the subject of textbooks. This is not a paid sponsorship.
Is it Rhinewick? Is it a Rhinewick? Sorry.
Yeah. Rhinework Computing.
Oh, Rhinework. Oh, I call it work. Oh my god. Rhinework gets, oh Lord, $60?
But reliable information, right? Yes, like it's money, but you know, man, yeah. As I said, I firmly believe we're entering the era where you're gonna want the textbook. Because, like, I've used these ones, they're beautiful, beautiful textbooks. Every course I'm gonna rewrite in the next 5 years is gonna be based on one of those textbooks. So, but yeah. Alright, git branch, good. When branches are merged, a commit message is required. Yes, good, yes. Yep. So yes, good, yep, after merging, yes indeed. You can still use the dev branch after merging. So, maybe you can just take my word for it that like if you do simple edits such as adding a line in 2 places, it can merge those seamlessly without having to, you know, it's smart enough to, so, you remember the diff program? You guys had to use it for like assignment 1, I think, right? Or something? Assignment 2? Yeah. That's like the utility that it's using to determine differences between files. So any situation where diff would say insertion, any case where diff would say deletion, those can be automatically merge fixed. Anywhere that diff says conflict, you know, this side, that side, that's a situation where you're going to have to fix one of those merge conflicts. Make sense? Cool. So I was a bit premature. I said, oh, you can, you should consider the dev branch closed once you're done. You've merged it back in. This is kind of because like this is how you should consider your workflow to work. But it is possible to still check into dev and to, you know, make more commits to that branch. basically what this allows you to do is like, you know, you may not be fully done the feature that you wanted that branch for, but you can merge, you know, you can merge some of it in and it'll be good. You got some of the feature working, you can put that in. There you go. I would argue that what you probably wanted was more than one branch, right? You've probably not sufficiently well divided your tasks into subtasks and assigned each subtask to a branch if you're doing that. But, you know, real development is what it is. Not everything is perfect. This is the type, you're not locked out of the branch after you've merged it. That's the point. Make sense? Cool. Yes. We can switch to master and merge the change. Yes, yes, yes. Yep. So you can see after you've done that type of a process, we branch off, commits here, commit there. We do a intermediate merge back into main. Then we make another commit in the same branch, merge that into main as well. You end up having merged into main twice, but you know, that's a thing you can do. Don't merge it into main unless it works. All right? Any questions? This is actually, I think, let's see here. Oh yeah, okay, so this is the example of like, okay, so let's say we have a file, right, on dev, add some content to file text, add a line to the bottom of file.txt on the dev branch, right? This line was added, right? If we commit on the dev branch, and then we modify it on the, so this is in the master branch. Notice the line we've added is the first line, right? Not the second line. Commit it. If we merge, the file is different on both branches, but if we merge it, auto merging file.txt, merge made by the ORT strategy. It works, no error message. You cat the file, we have the line on top, we have the line on the bottom, both were added because they're not the same line, right? In our case, we created a conflict because all of our changes occurred on the same line, right? Does that make sense?
Mm-hmm.
Good. I can do a live version of that. Do you want me to do a live version of that?
No.
No? You got it? Okay. It's getting late. I don't know how much. All right. So. Yes. So in that case, we were doing non-overlapping changes. The slides, like we're ahead of where we are in the slides, right? Because the slides are about to do. Yeah. Okay. Let's go through this then. So, what is happening on the dev branch after a merge? If we switch back to the dev branch and look at file, it's missing a line, right? Why? Well, because it's not the commit that we just made, right? We're checking back into earlier in the history before the merge was made. The branches themselves don't merge so much as we merge changes from a branch into another, right? So let's say this is your commit history, right? We branch off of main. Main has a commit. The branch has a couple of commits. We perform our merge. We have our new master, right? If we check back into the old branch, what commit are we checking back into? The one with the arrow, right? We're checking back in here, which is like earlier in terms of history, right? So if you're expecting important work to have happened here, that work will be gone if you check this branch out again, right? But you shouldn't be doing important work here, right? You should, all this should be is just merging, right? So branches are effectively pointers or references to commits. And after a merge, our branch, dev branch pointer is still pointing to the previous commit on this branch. If we were to make changes on this branch, they wouldn't be reflected, they wouldn't reflect the differences on the main branch. That's another thing to keep, another thing to keep in mind. As commits are being made on the main branch, you are not receiving them up here, right? You are on a separate timeline, right? So I understand, like, Git gets a little tricky because you kind of have to think about time travel, you know? Like, that's not a bad way to think about it, though. It's like, right here, you know, our universe split into two timelines, right? This is the timeline that proceeded from these decisions, but does not contain anything in the parallel universe, right? And vice versa. This guy doesn't get anything here, this guy doesn't get anything there, until, you know, it's interesting, when you talk about time travel movies and that sort of thing, you don't really get a lot of, like, merging in the future of timelines. It's always, they're always concerned about splitting off in the past of timelines, you know. But, you know, if you took the two timelines and you merged them into the same universe, you know, making all the differences between the two universes harmonize somehow, that's how it works, right? But basically, like, your branches should kind of, in a sense, be short-lived, right? Like, they shouldn't exist for too long, right? Like, consider it this way, right? If you pick a branch off of the main timeline, and you did that 2 years ago, right? There's a lot that isn't on your branch, right? So, I don't care if it's taken you 2 years to work out that feature. 2 years of work should modularize at a finer level than 2 years of work, right? You should be able to split that task up into smaller tasks and branch them out properly, merge them back in properly. The longer it's been since the branch was picked off, the more sort of accumulated change debt you have incurred, right? So it's like, get in, make your changes, merge it back, get out, right? Ideally, anyway. So. While it's not universally practiced, it's actually very common to just delete the branch after your feature has been created. Branches are created to make changes. Once the changes are made, the branch is merged into master, after which the branch is not used again. Instead, it is deleted. We could also merge the master branch into dev. The advice of Kevin, who made the slides, is use new branches for new features. Old branches for old features. They do have to be, like, you can merge a branch into main, but you can also merge a main into a branch, right? So this is one way that you can, like, you know, say you have a branch that's been open for like 3 months and there's a major revision in main that you need to you need to incorporate those changes into your branch or you won't even have a hope in Hades of being able to merge it back together, right? You can merge main into your branch, right? Take the changes from main, put them with you. That way you'll have to square the merge conflicts, but you'll have the up-to-date version from main, right? But it doesn't happen automatically, and it takes work, right? So, yes. Yes. It is possible to delete a branch, git branch -d branch name. So you can delete branches that way. So this does not delete the commits, right? All it's doing is deleting the pointer. Note the difference. Prior to deleting the branch, after having merged, we have both main and dev pointing to the most recent commit, this one, right? After deleting the branch, we have not deleted like what you would semantically think of as the branch. We haven't removed any commits from the repository. That's a terrible idea. Never delete commits. Commits are not made to be deleted, right? What's been deleted is dev. Dev is no longer appearing in our repo, right? So we've lost that branch name, which we were using to keep track of these commits and refer to them quickly and easily. If we want back in here now, we're going to have to enter that. Or a shortened version of it anyway. Oh, did you know that? If you take this long thing and you plug that into checkout, you can check out any commit from the entire history. Pretty cool, right? You want to know what's more cool though? Watch this. Oh. Log back in, you. So, cat file1.txt, all kinds of stuff. Let's say I made a horrible mistake. Git revert file1.txt. Oh, bad revision. Maybe, probably because the last one we did was a merge, right? Here. File1.txt. Pointless nonsense. There we go. So now file1.txt contains pointless nonsense. It's like, oh, come on. I'm going to commit the nonsense. No! Oh! I get most of the way through it each time too. Okay, now we change the file. Give me a normal one. More pointless nonsense. Git revert file1.txt. Come on. Alright. I don't think I have a slide on that one, so I'll just, that's possible under certain conditions. Alright. So, many large projects have naming conventions for branches, as you might expect. If you take a look at this one, The issue tracker ID is used in the name of the branch. That's a good idea, right? This is the branch for this issue. Very good. Short actionable description of what the task is talking about. Add billing module. Use hyphens as separators. I just learned from the slides for the databasing course that this is called kebab case, which I think is just kind of silly, but that's okay. All right. Okay. Can I level with you? I'm kind of out of steam, you know? You guys out of steam?
Yeah.
Yeah.
For the last 10 minutes.
Yeah. Normally I go for the next, you know, we don't have that much left to do in this one, you know, but I'm sorry, I thought we'd be able to get through it, but, you know, it is what it is.
It's all good.
Yeah. I hope that you find the class interesting even if
Yeah,
it contains,
Yeah, it
you
does.
know, a few tangents. I mean, it must have at least been entertaining to hear me rant about AI. We aim to please. But yeah, we'll pick this up next week. We are making progress, like we're not as behind on the slides every week. So that's something, right? But yeah, we'll finish this off next week. Everybody do your assignments, get them in on time. Go home. Go home, everyone.
Next week, the older reduce 20%